Find the derivative of g of t equals the cosine of 4t divided by 3 plus the sine of 4t. So g of t here is the quotient of two functions. We have the cosine of 4t divided by 3 plus the sine of 4t. We'll have to make use of the quotient rule for the derivative here. So g prime of t will be the derivative of the numerator, derivative of cosine is negative sine. Leave its inside alone, but then multiply by the derivative of the inside to complete the chain rule. Derivative of the numerator times the denominator left alone minus the numerator left alone, a cosine of 4t, times the derivative of the denominator, which will be a 0, and then plus the derivative of sine is cosine 4t, but then multiply by the derivative of its inside to give you a 4 for the chain rule. All of this is divided by the denominator quantity squared. So I'll make this look a little bit nicer. I'm going to write the 4 before the sine. So I have negative 4 sine of 4t. I have a 3 plus sine of 4t. And in the second term, I have a 4 that can move to the front, and then I have a cosine times a cosine. That's cosine squared of 4t. And all of this divided by that denominator, 3 plus sine of 4t quantity squared. Now in the numerator, I'm going to be able to distribute this into all of this. So let's go ahead and do that, because we may be able to simplify this further. Negative 4 sine 4t times a 3 will be a negative 12 sine 4t. And then a negative 4 sine 4t times a positive sine 4t will be a negative 4 sine squared 4t. And then we have the negative 4 cosine squared 4t, all divided by 3 plus sine of 4t quantity squared. Now back in the numerator, I do have a sine squared term and a cosine squared term, and whenever you have that, you might want to look a little closer at it to see if we can get that identity where the Pythagorean identity says that those added together will be a 1. What you need to have is the phases need to be the same. The phases are the same. These are the phases. Okay, those match. And it turns out you need their coefficients to be the same. And, well, the coefficients are the same. They're both a negative 4. It's okay if they're both negative right now because we factor that out. So in our next step, we have the first term left alone, but we can factor a negative 4 out, and that will leave a positive sine squared of 4t and a positive cosine squared of 4t. So that's why all we need is a matching coefficient on the two of them. They have to both be squared and have matching phases, and you will have the identity. The Pythagorean identity says all of that is equal to a 1. We'll leave the denominator alone. So all of this, according to the identity, will be a 1. So g prime of t can now be written as negative 12 sine of 4t minus 4 times a 1. Denominator left alone. And then 4 times 1 is just a negative 4. We will be able to factor this a little further, so let me write this result for now, but it looks like we have a common factor of a negative 4. In the numerator. And if I factor a negative 4 out, that'll leave us with a positive 3 sine of 4t, and then plus 1. And then over the denominator, which we'll leave alone, And though the numerator factor looks kind of similar to the denominator, it is different. It's a +1, not a +3, and the 3 is with the sine of 4t, so we can't cancel anything, but there is the factored version and simplified version of our derivative g prime of t.